Hello, fellow developers. I hope you are all doing good. So, for this session, if you are eager to learn about a Spring backend system which creates AWS RDS instance and manage the database schema using Liquibase, an automation tool, and plus use Terraform and infrastructure as a code configuration system which automatically builds and creates or provision the AWS resources for you. So this is the right video for this session. In this video, as you can see on the title, we're going to discuss about Spring RDS backend system. The topics that we are going to cover is Spring Boot, AWS RDS, Liquibase and Terraform. So if you are working on any project, any mature project, then there is a requirement of creating certain tables. And for creating these tables, it becomes very cumbersome if you're gonna create a lot of tables, if your schema for your application is huge, and to create them manually is a big challenge. And also to manage the changes being done on the table schemas, if you have a team of more people, then it becomes a lot of challenge. So in order to easy out the process, there is a tool that we use a lot. It's a mature tool in many of the projects. The tool name is Liquibase. Liquibase is a data migration tool, not a data migration tool, a schema migration tool, which helps to do the change control on our database schemas and also use it for deploying the changes based on our needs. So these are the topics that we are going to learn. Liquibase on a very high level. Then we will build a Spring Boot application which would have an infrastructure package that would provision AWS RDS infra for our database. It will create an RDS cluster on which we're gonna push some table schemas using Liquibase. Then how do we set up the Liquibase with the help of Spring Boot application is something that we're gonna learn. And finally, once our backend system is run and the database system is set up, we'll check the table schemas by making a SQL connection with the help of some software tools such as DB and verify the table schema that we were expecting is created. So let's begin. First, we will move to the repository, GitLab repository that I have. Uh, this is the GitLab repository that you can access. The most of the codes is already been written here. Let me explain you the README file of this project. So this is a Liquibase RDS MySQL schema management tool. Please note the schema management tool and with Spring Boot and Terraform. So these are the tech stack that we are going to use. We are going to use Spring Boot. We're going to use Spring Boot 3.x version, the latest version. We'll use the Liquibase 4.27.0 version. It will have an MySQL instance which will be running on an AWS cloud infrastructure and use Terraform AWS provider to automate the process of provisioning the AWS resources. And then the build automation that we are going to use for our Spring Boot application is going to be Gradle build tool. The project structure is going to be simple. It will have a source main resources, and within resources there would be a DB and a change log. So let me give you a little bit of an overview of the Liquibase. So Liquibase is a change control for your database. It's similar to how we have a source code control with the help of Git, right? Similar to that lines, this is Liquibase, which will help to control the changes that have been done to our database schemas. And each database schema changes is denoted by change log file changelog file that we'll take a look at. So already I have a repository clone in my IntelliJ. So I'll move to this project, and if we look to this project, there is an src main java, and there has to be one particular file under resources. Yes, so here in the db.change project we have multiple files. Changelog files, these are basically called as changelog files. So, and these files can be written in any format. A YAML format is fine, an XML format is fine, an SQL format is fine. So Liquibase is very much supporting all the different XML files and YAML files that we have are aware of. So in this project I have taken a reference of YAML file. So here basically we can see it's a change set. It's a log of different change sets, which is indicated by a unique ID, author name, and then the changes. So in this particular YAML file, we can see it is gonna create an articles table. So here are the change sets that we're gonna define. So first change set, we define the ID, it will be unique, author name, changes, create a table. The table name is going to be article and the column details that we want to create. Similarly, we'll create another table with the comments of the table name, and you can see the change here. The ID is 2. So for each change set, the ID has to be unique. If the ID is not unique, then it will lead to Liquibase update error and the project won't work. So it needs to identify each change set uniquely so that it knows in which sequence and in which order the changes have been done. And all these details will be internally stored by the change log tables and the change locking tables. So these two tables are automatically created by the Liquibase when an update command is run. And finally, we have a 03 add sample data.yaml file where a change set indicating insert operations with different insert tables, insert columns, and values are being added over here. So you can see YAML is pretty simple of for creating tables and for adding some table data. So basically what we're gonna do with the help of the Liquibase Spring Boot setup is that we're gonna migrate this schema or the change set or the database change log onto an RDS instance which will be running on our AWS cloud server. Correct. So for this automation, I have first step is to automate the process of provisioning the AWS resources, right? So for that, I have utilized the Terraform as an IAC configuration script. So under this infrastructure folder, you can see there is a Terraform configuration file for networking, which will create our own VPC. Then within that VPC, there would be two public subnets named as public X and public Y. Then there would be an API internet gateway, which will allow the application to connect from the internet, from the public internet, and there would be a route table obviously, so that it sits between the VPC subnet and the internet gateway. Then there would be route table association. So these are the basic Terraform configuration file that will be used for our networking. Then there is a provider, obviously this is used for setting up what provider we're gonna use for our Terraform. So we require providers, we setting it to AWS, and then the region which we are gonna work with. So these are the basic projects or the basic Terraform setup. And finally we're gonna spin up an RDS instance with the help of AWS DB instance, and the instance type would be of MySQL, the identified by this name, its storage type, engine, and all those things. So these are the basic things that we have done to set up our AWS infrastructure. So once this infrastructure is ready, what we are gonna do is we gonna set up a Spring Boot application. Spring Boot application will connect to the endpoint that will be generated by our RDS endpoint, and on that RDS the Liquibase will run the schema migrations that we have just created over here. Correct. Fine then. The second part of this video will discuss how do we set up the Liquibase with a Spring Boot application so that it connects to the RDS and push all our schema changes. As of now, we are good. Let's connect in the next session. Thank you.